What's up, guys? HVAC Dave back at it again. Another day, another fucking rooftop. Today we're dealing with this old piece of crap Carrier Weathermaker. Would you look at this beauty? We found one of our transformers in this unit fucking defective. So today we're gonna change it. There it is up there. It's a process getting it up here too. Let's get to it. This transformer here is a beast. This has to go up to the roof. Let's see what she weighs. £40. Cardboard might be what? 1/8 of a pound, so a 40-pound tranny going up to the roof. Don't you guys love carrying trannies to the roof? Just took off the electrical cover. This puppy's in rough shape. I don't know the year of this unit, but I would guess early 90s at some point. 3 decades old at least. And there's our transformer back there. I don't know how I'm gonna get my ass in there. Might have to take that condenser fan motor off and come in from the top. I can tell you one thing, my 210-pound ass ain't fitting in that little hole. All right, guys, so I was here a few weeks ago. The customer was mentioning they had no air conditioning on the main showroom floor. This is an instrument store, so which is a problem. I mean, the instruments in that store have to be at a certain humidity level, and it was skyrocketing, going up past the 60% range. And most electric guitars, acoustic guitars, and instruments that are wood in general would have to be in that 40 to 45% humidity range. So this air conditioner plays a big role in that ground floor cooling system and maintain the humidity level. Because what do ACs do? They dehumidify. Anyways, I'm gonna show you how I came down to the conclusion that that big shoebox size transformer that weighs 40 pounds was defective. All right, so we'll turn our power on. And the first thing we'll do is we'll check our lines in from our disconnect. So if you watch my meter here, we're looking for 600 volts across all 3 phases. What do we got there? We got 600.9 from phase 1 to 3. Phase 1 to 2, 600.3. And then from phase 2 to 3, 600.6. So we know we got our inlet power. Our fuses are not blown, our breaker's not tripped. We're good on the inlet side. Okay, so that big transformer has 2 purposes in this unit. One is to provide 208 volts for our blower fan, and second is for this control transformer here. They're trying to bring our 600 volts down to 208, 230, and then this transformer here takes our 208, 230 to 24 volts. So the 24 volts we don't have available right now because that big transformer is blown up, and I know that because I went across our R terminal to ground here, and we have nothing on our meter. And I also checked our inlet power here to our control transformer. And this is a multi-tap. You can set it for 120, 208, 240, or 480 volts. I think 480 would be more popular in the US, but here in Canada, we don't really have that. Not with the equipment in the recent few decades anyways. So we're going across our common, and this is our 240 volt tap. We'll jam our lead in here, and we have nothing, no power. So we have our main inline power, which is fine. We just don't have our control power because we don't have 240 volts from that big shoebox transformer. I've also verified our compressor isn't seized. I mean, it is ancient, and I've done that just by using an insulated screwdriver here that I broke the tip off, but bumping this contactor. And there you go, you guys hear it. The compressor is running away. It's a recip. Condenser fan motor, however, is not coming on. I believe that might also be off of our control transformer. But let's start changing this thing. All right, power's off to the unit. This is our only real access we have. Old rusty screws. Oh, she's heavy. Okay. Now we can get some access to this thing. Okay. So this transformer here looks like it has 4 5/16 screws that hold it in place. Let's pull this thing out. Oh, that's nice though. They have like an eyelid, an open size, so you can kind of only back your screw off a touch. And you don't have to physically support this when you go to remove it. Let's go. Let's pull this thing out. Yo. Okay. Okay. Up she comes. Okay. Thank you, Carrier, for leaving extra length and wire. All right. Beast. All right, let's open up this old transformer here. See what our wiring connections look like. Wow, everything's just so old and rusted out. And one more. Okay. Let's loosen off this screw. So maybe we can pull these wires through afterwards. I hate slot head screws. All right, that should be okay. Now what I like to do is, I like to cut these wires inside with the color we have corresponding. That way, if I'm ever in doubt, I can always look back at how it was wired in. So what I mean by that is we're going to cut our colored side here just below our moret, one at a time. 1, 2, 3, and these are our grounds, but we'll still cut them back here. 4. We can pull our old wire chase out, and that way when I want to look back on what went where, at least I have a reference here. So that's what I like to do. We're going to reuse our old box connector here. This is 3/4 inch. So we're going to break out the side of this enclosure. That was easy. Sometimes they don't make them quite that easy. Oop, might be a little much there. Hold on, we don't want to break out the entire section. Can't always do everything perfect, guys. Let's bend that back into place before it breaks. Now I know someone's going to rip me for using an insulated screwdriver as a pry bar essentially, but that's just how I roll, you know? Come on. These are always a pain in the ass to break out. Got one side of it there. All right, let's see if we can get a longer screwdriver in here. There we go. If you guys have a stepper bit, I mean, yes, it probably would be a better option, but I don't have one with me right now, and I'm not going back down the ladder to my car just for a stepper bit when you can do that. There we go. So there we go. Connection's out. That's in place. Let's put this box connector in here. Nice. Kind of just holds in place like so. Let's get our wires. See if we can feed these through. Okay. And the protective tape, I'm guessing it came with from factory. I'm going to set it back a little further so I have more room to work with in here. Let's stand this bad boy up. Okay, and we'll tighten these set screws down. Holy shit. Rusty, rusty, rusty. I'm genuinely curious the date on this rooftop. I almost want to call the manufacturer and find out. And there we go. Wires are in place. We're in our box. Let's wire this SOB in. I think it's going to storm here in a second, so let's try and hurry up with this. But H1, which is one leg of 347, was our black wire here. And that's going to go to our H1 on our transformer, according to the diagram I showed you guys a minute ago. Trim this back. Barrette that on. So there's one leg of 347. And H2 was white. Let's strip this back. And I know someone's going to rip me too for using side cutters or dikes to strip wire, but man, if you know what you're doing, you've been doing it long enough, you're not going to fuck up the wire. Let's face it. H2's white. And we'll even go a step above from whoever put this other one in, and we'll tape these connections up. Throw a bit of tape on these. Not that anything's getting into this box, but hey, good practice, right? You electricians out there, you let me know in the comments. Let's go. There's our 600 volts. Let's wire in the rest. Okay, let's tie in our 208 side now. So X1 went here, and I had to use a bigger Marette because there's 3 wires on this side. Whoever put this in the first time used a little orange Marette. That's fine for 2 wires. Not always though, depending on your gauge size, but this wire here is not overly big. This might be 12 and 10 gauge, maybe not even, maybe 14 and 12. Not 100% sure, but anyways, here's the other side of our 240 volt connection. And that Marette's no good. We're gonna have to get a new one. Oh. Tool bag stock kicking around in the bottom. Saved me a trip. All right, so X4 is in. So again, just to go over that, this is 347 volt, 347 volt. That equals 600. That's our inlet power. And these have to be joined together according to our diagram here, which I'll show you quickly. So on our 240 volt side, and then X4 and X1, I believe. Yep, X4 and X1 are our other 2 connections, X4 and X1. Let's go. Let's put this bad boy in place. Actually, before we put this big boy back into place, I'm going to show you guys quickly how you can ohm out a transformer of this size, or any size for that matter, with your meter. Because this transformer is very, very expensive. You don't want to go changing parts if they're not needed, especially at this value. So we're going to set our meter to ohms. Usually touch your leads. You'll hear a little beep, register some resistance. Anyways, so we're going to check our H1, H2, because we know H1 and H2 are line voltage ins. So you see that? We have 2.6 ohms resistance across the primary side of the transformer. Now, if we go to our secondary side, which was X4 and X1, we have X4 and X1. Let's do the same thing. And we're reading nothing. X4 and X1. I'm on both leads, X4 and 1. And we have outer limits. So it's open. The windings are burnt up. There's a break in them somewhere. Who knows? But this transformer is trash. All right, so I had to drill 2 new holes because our old transformer was about 1 inch wider on each side. Go figure. Everything that's older is generally made better. But it's really going to save me here because now I can just hook these on like so. So let's set these into place. Beautiful. Awesome. And if you notice too, our old transformer had screw supports on the bottoms. This new one doesn't. It's just two off the top. Whew. All right, well, let's clean up these wires, put this unit back together, fire the power on. All right, let's try and clean up some of this fucking mess here. What do we got here? All right, let's start with this bunch of wires. Imagine at one point in time, these were all neatly tied up, but considering this unit's 3 or 4 decades old, it's probably been serviced over 100 times. And people don't care to make things somewhat neat. No, it's not going to look excellent by any means, but might as well try and tidy things up a bit. Like, look at the sheer bulk of wire here. This is fucking nuts. When equipment was made better, nowadays, you'd be fucking lucky if you had a spare 3 inches of wire going to any one of your loads. Every manufacturer has gotten so cheap these days, guys. Panel doors essentially are made out of tin foil. The screw holes for the panel doors strip after the first time you use them or go to service them. A lot of units now looks like Swiss cheese in the filter door, because you get guys end up having to drill new self-tappers because the manufacturer's pre-made holes are only good for one time. All right, well, that's looking a little bit better. Let's turn this on and see what happens. All right, let's turn the power on. And we got no dice. Excellent, more problems. Do we have 24 volts? No, we do not. What do we have here? Oh, I didn't see this. This fuse, how much do you guys want to bet the old transformer took that fuse out? Let's at least check the back side of this. There's our 208 we were looking for. See it? Oh, 212. 240. When I got a good lead on there. But I bet you this fuse here is blown because we lost that transformer. All right, let's see what kind of fuse it takes. Holy smokes, man. That is rusty and old. Oh, well, there's our fuse. That's our cap. Great. This thing is so rusty. Oh my gosh. Okay, well, yeah, I'd say that fuse is pretty fucked. Oh, God. All right, well, what we're going to do for the time being, because I don't have a fuse, we're going to bypass this fuse holder by taking our power in and just joining it to here. And we'll have to come back another day, probably with a new fuse holder and fuse. So let's do that now. That's our power from our transformer. That's feeding a terminal board, or like a terminal strip back here, which in turn will give power into our 24 volt, 240 to 24 volt transformer, which powers our terminal strip. And our unit should start right up after we bypass this fuse. So let's quickly do that. We're going to cut this clip off. And yes, I'm using wire strippers now. Haha. All right, let's join these wires together. Let's put our Moret here. Okay. Fuse is bypassed. All right, power on. Oh, we got a smoker. Would you look at that? I can smell the smoke already. That probably took out our transformer from day one. Think we need a blower motor now. Make sure this is off. Let's see what's going on. Is something seized? Nope, motor is free. All right, let's investigate. All right, guys, we popped the lid. I've held it up with this panel, had to take all the screws out. It's really the only way to get access to this blower motor though, unfortunately. Took a quick look at the wires. I mean, I don't see any shorts in the casing. They're so dirty, it's hard to tell, but I want to bump this on really quickly and just see what happens for a split second. So let's try that now. Okay. Not sure if you guys could hear that, but that motor is burnt to hell. All right, well, we're gonna have to go talk to the customer. Maybe we can pull a motor out of the Carrier unit over here. It's in a less critical area, and then replace that one later to get this one going. But we'll find out. Let's see. All right, so we verified that the blower works in this unit, and the customer doesn't even use this rooftop right now. They just leave the thermostat in the off position, which is working out great for us. Unfortunately, it just started raining. I don't know if the camera's picking it up, but of course it is. Why wouldn't it rain, right? Right in the midst of all of this. Anyways, I think what we're gonna do with this, we're gonna pull the entire housing out and just swap them. I believe it's only these 4 screws here, 2 on the top, probably 2 on the bottom. Should slide right out. We'll carry it over, swap them out, start it up. There's a little support stand in the back here that we have to take the screws out. Okay. One more. Okay. And yes, that was a little bit of a rookie mistake. I should have checked the load that was being driven by the transformer, but hey, we all make mistakes, and today it kind of worked out for me because we had a unit on the roof that wasn't being used. So I'm happy about that. Okay, old equipment. All right, let's see what else we got here. And I believe there's 2 on the bottom. I think that's it. No, we got a couple more here. All right, we're ready to slide this blower out. Okay. Not too bad. What did we forget here? One of our grounding screws, I guess. Yep. Let's take that off. And out she comes. So when I opened this panel door, look who was there to greet me. They are not happy to see me. Wasps and HVAC guys do not get along. All right, let's slide our good blower into place. By the way, I'm getting soaked out here. All right, let's fire these in. There's one. These are just a bracket support. to take the weight of the housing. Cool. Now we're gonna hook back up our high limit wires. 1, 2. Put in our common for our cap. Nice. And then we got power for our motor, which is here. This is a multi-tap motor, so it's multi-speed. We're gonna put this one on the highest speed. Right in the back there. Show you guys quickly. So those are our speed taps in the back here. We put it on the highest speed. Here we go, round 2. Power's on. Blower kicked right on. That's what we're looking for. So I've tied all my wires up here. Everything is all tied in so that fan will never suck anything in and chew them apart. We're good. Let's throw our gauges on, make sure the cooling works. By the way, guys, I got a little surprise for you. You ready? Let's go. Brand new dials for my gauges. No more shaky pressure readings. And we got a clear sight glass here so I can demonstrate a little bit better for all you guys. All right, guys, gauges are on. We're running on our 22 scale here, our green scale. Indoor coil temperature, 36, 38 degrees. Head pressure around 200 PSI. It's about 70 degrees Fahrenheit. It was down in the space a minute ago. It wasn't overly hot because today it's rainy and kind of mild, but this unit's running great. All right, guys, that's a wrap on today. The main takeaway from today's video would be, if you have a transformer that's bad, please check the load it provides power for, which is something I didn't do and I usually would. So I'm glad you get to see my fuck ups too. Everybody makes mistakes. I don't care how long you've been doing this for, but yeah, if you guys enjoyed the video, please like, subscribe, comment, and check back in for the next one.